Alright, I want to make a little video to explain some of this Chapter 4 review. So, first of all, logarithm is an exponent. Hopefully you can see this, hopefully it's zoomed in enough. For number 2, what you want to do there is you can bring the 3x out in front. So, and then natural log of e, of course, equals 1. So we get 3x. And then this one, if you set it equal to x, then you can change it from logarithmic form to exponential form. And then you can probably easily tell that x equals 1 because the bases are the same, so the exponents have to be the same. Number 4, you can set it equal to x and then change it to exponential form again. So 7 to the x equals 1, and so 7 raised to what power would have to equal 1, and so that have to be x equals 0. Number 5, you can set that equal to x, and then whenever it doesn't have a base, we know it's log base 10. So that's 10 to the x equals 10,000, and you can just figure out, 10 raised to what would give you 10,000. However many zeros there are, that's how many times you have to multiply by 10. Number 6, you set that equal to x, so that's 2 to the x equals 32. So x has to be 5 once you break down the 32, make it 2 to the 5th. Number, 7, change it to log form, log base 5 of 25 equals 2. And then you can see number 8, very similarly. Let me skip down to number 10. Number 10, if it's natural log, we know that's the same thing as log base e of 4. And then we can change it, we can say it's e raised to 1.3863 equals 4. Alright, the change of base formula, all you do is you can use either log or natural log, whatever base you want, but that number, the 10, goes on top, and I remember it because the base is the one that goes on the bottom. And then we just use our calculator, you should get 1.661. Same thing for the next problem. 13 and 14 is where you want to squeeze them together a little bit using your properties. So the 2 can go out on top as an exponent, and then 5 can go on the z as an exponent, and then there's a plus sign in the middle, so that means we can put them together with multiplication, and that's it. That's all we can do. Number 14, you move the 2 over as an exponent. The 1/3 you put on the y, and then the 4 you put on the z. And then you start squeezing them together a little bit. So there's a plus sign right there, so you can multiply those. And then there's a minus sign, so you can divide. You can put that on the bottom. And the only other thing I did was it was y to the 1/3, so I made it the cube root of y, which is the same thing as y to the 1/3. Numbers 15 and 16, it's the same thing but the reverse order. First it has a division, so I make it minus, and then it has multiplication, so I split it up with the plus sign, and then it had a 2 as an exponent, so I just put that out in front. And then similarly for number 16, made it subtraction first, and then there was multiplication here, so I split it up with the plus sign. That square root of x is the same thing as x to the 1/2, and so then I just put it in front. Alright. Next page. Alright. For number 17, what I did was divided by 4 first, and then changed it from exponential form to logarithmic form. So log base e of 91 over 4 equals x. Log base e is the same thing as natural log, so just plug that into the calculator to get the decimal. Same thing here. I could have done this a couple different ways, really. I changed it to exponential form, but I didn't have to do that. So I did e raised to the 9 equals e raised to the 2x plus 1. Now the exponents, you can set them equal, and you should get x equals 4. I guess the other way I could have done that is to put the 2x plus 1 in front, and then natural log of e would have become 1, and then I would have been able to proceed from there. Number 19. Let's see. T equals 0, that means you plug in a 0 for the t, anything to the 0 power equals 1, so you lose this whole e business, and it just turns out to be 105,000. Part B, it says when will it have a population of 150,000? You plug that in for the p and try to solve for t. So divide by 105,000, and then change, well, then I took the natural log of both sides. And then that allowed me to bring the 0.05t out in front, right there. And then divide by, natural log of e becomes 1, and then divide by 0.015. Do that on the calculator, you should get 23.7. Now they want to know what year that is, not how many years beyond 1990. So we take 1990, you add, if you round it up to the next year, it would be 24 years. So 1990 plus 24 years, it's about, it's about 2014, okay. And then number 20, how long will it take to double? Well, it's 1,000 right now, so let's make the amount of money double that, so 2,000. Divide both sides by 1,000, so that's 2. And then change it to logarithmic form, so natural log of 2, or log base e, which is natural log of 2 equals the exponent, which is 0.12t, and then divide by 0.12, and that's calculator. Number 21, you want to graph this. So you know exponential functions typically have a horizontal asymptote of y equals 0 right on the x-axis is the horizontal asymptote. But that says -2, so that means it's shifted down 2 units. So that's why I have a horizontal asymptote here. And then I want to figure out, okay, where does this cross the y-axis? Well, it usually crosses here at 0, 1, so it's shifted down 2 units, so it's at 0, -1. So that's what we got. Number 22, when will the account have 35,000? So plug in 35,000 for the left side, for A, and then solve for T. When will it triple? You make it 30,000 and then do the same thing. Solve for T. Number 23, it's compounded quarterly. So now for the n, we use a different formula. We use this formula. We plug in the n of 4 in both 2 spots, there and there. And then, do the math, and you should get 16,310.19. Solve the following equation. So this is a plus sign, so you can multiply them together. They both have log base 6. The right side doesn't have a log, so we have to change it to exponential form. 6 squared equals x squared plus 5x. Slide everything to one side, factor it, and the only one that works is +4, because -9 would give you a negative argument. Okay, the most challenging ones are probably like 24b. So first you have to take the log of both sides. And what that does is that allows you to take the exponent and put it out in front. So take this exponent, put it out in front, and then you distribute the log 3 to each of those. That's why they both have a log 3. And then log 4, same thing. And then you try to get all your x's on one side, so anything that has an x, you move it to the one side. I moved it all to the right. It was a little bit easier. So I moved the things that had x's to the right, the things that didn't to the left, and then I factored out an x, saw what was left, and then divided all this on both sides, and that isolated the x. And then you scrunch it all together using your properties. So that's, the 2 goes on the 3, so that's going to be 3 squared. It's a minus sign, so you can make a division. This is 4 squared, it's a plus sign. This is 3 cubed, so that's going to be 27. There's a plus sign in the middle, so, oh, I jacked that up, darn it. Oh well, I'll have to fix that. So that's a plus sign, that should be multiplication, so don't copy that one down. I'll have to fix that one, but that's a good lesson for me. So plus sign, make it multiplication, figure out what the decimal should be instead of that. Okay? Good enough.